If you think we already understand everything that enters our solar system, this story will challenge that belief. A mysterious object called 3I Atlas has arrived from beyond our stellar neighborhood, and new images are changing how scientists see it. Not through speculation or science fiction, but through raw data and careful observation. What these images reveal is quieter, stranger, and far more important than any wild theory about humanity's place in a vast cosmic ocean. I-Atlas is only the third confirmed interstellar object ever observed passing through our solar system. Unlike asteroids or comets born around our sun, this object originated in another star system entirely. It was ejected long ago and drifted through interstellar space before crossing our path. That alone makes it extraordinary. Studying 3I Atlas allows scientists to examine material formed under completely different cosmic conditions. In a very real sense, it is a visitor carrying physical evidence from a distant stellar neighborhood we may never otherwise reach or explore directly. The new images of 3I Atlas reveal far more than a faint dot drifting among background stars. High-resolution observations clearly show a surrounding cloud of gas and dust called a coma, along with the early development of a subtle tail. These features indicate active outgassing as the object approaches the sun and warms. That behavior matches expectations for a comet rather than an inert asteroid. More importantly, variations in brightness and structure suggest uneven activity across its surface, likely driven by unfamiliar chemical mixtures. Each pixel represents measured data, not imagination. Together, the images confirm 3I Atlas is dynamically evolving and responding to solar radiation in ways scientists can model, test, and directly compare with known comet behavior. This observational clarity allows researchers to discard speculation, refine physical simulations, and focus attention on processes shaping icy bodies when exposed to stellar energy far from their birthplace, across interstellar space itself today. What makes these observations truly important is not simply that 3I Atlas is active, but that it behaves differently from comets formed near our sun. Its gas release rate, dust distribution, and thermal response do not perfectly align with existing models. This implies formation under physical conditions unlike those in our solar system. By analyzing these deviations, scientists gain insight into how planetary systems evolve elsewhere in the galaxy. It challenges the idea that our neighborhood represents a universal standard. Instead, 3I Atlas points to a wider diversity of environments, forcing revisions to theories of star formation, disk chemistry, and the processes that shape planets throughout the Milky Way. Such findings help astronomers recalibrate expectations, design better observation strategies, and prepare for future interstellar detections that may further redefine assumptions about cosmic uniformity, planetary origins, and the frequency of truly alien materials entering our solar system from distant stellar neighborhoods beyond Earth. As with earlier interstellar visitors, the discovery of 3I Atlas quickly sparked speculation beyond the evidence. Some voices proposed artificial origins or intentional control. However, the latest images provide no support for those claims. The object shows diffuse gas, irregular dust structures, and brightness variations fully consistent with natural comet physics. There are no sharp geometric edges, no repeating patterns, and no anomalous accelerations that require exotic explanations. Science progresses by testing ideas against data, not by amplifying mystery. In this case, the data repeatedly points toward a natural origin, shaped by radiation, gravity, and chemistry. Removing sensational interpretations does not weaken the story. Instead, it strengthens the scientific value of 3I Atlas, allowing researchers to focus on measurable processes and reliable conclusions. The true excitement lies not in imagined technology, but in understanding how nature operates across vast interstellar distances without compromising rigor, clarity, skepticism, transparency, repeatability, and observational discipline standards. One of the most compelling ideas raised by researchers is that 3I Atlas may be an ancient remnant from a star system that has fundamentally changed or disappeared. After being ejected, the object could have wandered through the galaxy for hundreds of millions, perhaps billions of years. During that time, its material would remain largely untouched by stellar heating. If so, 3I Atlas functions as a true interstellar fossil. Its ice, dust, and chemistry preserve information about conditions around another star long before Earth formed. Studying such an object offers a rare opportunity to examine planetary building blocks from outside our solar system. In that sense, 3I Atlas is not just passing through. It is delivering physical evidence of cosmic history, allowing scientists to reconstruct environments that shaped worlds far beyond our own. These insights expand comparative planetology, refine formation models, and deepen humanity's understanding of how common, complex systems truly are everywhere. Discoveries like 3I Atlas suggest that interstellar visitors may be more common than once believed. New telescope surveys will likely detect many more in the coming years. With earlier detection, scientists could track these objects longer and in greater detail. Some future missions may even attempt close flybys. Each encounter expands our understanding of the galaxy and our place within its vast, interconnected systems. The new images of 3I Atlas do not make the universe feel smaller or more predictable. They do the opposite. They remind us that our solar system is open, not isolated. Material from distant stars passes through our cosmic neighborhood, carrying stories written long before humanity appeared. 3I Atlas is not a mystery that needs exaggeration. Its true significance lies in what it quietly reveals through physics, chemistry, and motion. The question is no longer what this object is, but whether we are prepared to learn from the messages it brings across the immense distances of space.